కరెక్ట్ ఉంది, ఇంకేమన్నా రాజేందర్ మంచిగా ఉంది.
ఓకే సార్.
రైట్, స్టార్ట్.
స్క్రీన్ షేర్. Good afternoon to all, respected DO sir and all physical science teachers and dear students. Today we are learning about how rainbow is formed, what reasons are behind it. Now our topic is dispersion of light and prism. Myself, B. Rajendra, School Assistant Physical Science, ZPHS Nutanakal. Here is a picture. We are observing 7 colors from violet to red color in the left side. And our topic is human and colorful world. This is the lesson name. Here we are observing another picture. White light is falls or incident on the surface of the prism, and it is splitting to 7 colors. This phenomena is known as dispersion of light. This phenomena known as dispersion of light. Now light source from sun or any lamp or torch light, it will be comes through a hole, a small light, a single light ray which is in white color. It will be incident on the surface of the prism, and it will be splitting to 7 colors. Light dispersed into components of color, that is a spectrum. This is known as dispersion of light through a prism. This is explained in that figure, and also there is an activity we will be see later. Now for this lab activity, we will be take a glass prism, place on table near a vertical white wall. Take a thin wooden plank with a small hole in middle and switch a light. The white rays coming out and falls on the prism. We can observe the changes in emerged rays of the prism in 7 colors, that is known as Vibgea. This is the process of the phenomena. White light incidents on the surface of the prism, and it will be splitting into 7 colors and forms that Vibgea. In the Vibgea, we can observe that 7 colors: violet, indigo, blue, green, yellow, orange, and red. This is known as visible spectrum. Up to red to violet or violet to red, there are 7 colors are there. Sir, video please. And fourth activity also there. This fourth activity, we can take a tray and water, a small mirror, and it put on the outer area opposite to that sunlight. There are 7 questions are there in our textbook. That questions are: what do you observe on the wall? First question. We can observe the 7 colors. Could you get colored image on the wall? Yes. Why does white light slip into colors? Due to the phenomena of dispersion of light. What color do you see? Violet to red. Can you notice any changes in the angle of deviation of each color? Yes. Which color has the minimum deviation? And why is this so? For these last two questions, we will be observe these this video, and after that we discussing about that 6th and 7th questions. Now let us observe the video, dispersion of light. We commonly observing a rainbow in the rainy season when rains comes, and after that. Sometimes from the oil drops also we can observe the spectrums, and also opposite of the light we can observe some spectrums. Through the prism also we can observe that splitting of light. This is known as Vibgya. For this activity 3, we can see this. A light ray is passing through the prism and it will be dispersed into 7 colors. Upper part we observing red color and lower part we observing violet color. A light is coming from a bulb. There is a small hole wooden plant. A single ray, white light ray is passed through this hole and incidents on the prism, and it will be splitting into 7 colors. And these 7 colors we will be see on the screen. These 7 colors, upper part is that red color and lower part is that violet color. Violet to red color, that is known as Vibgya. This is the phenomena of dispersion of light. These 2 activities are considered in our textbook. So that's why lab activity 3 and lab activity 4 is there. Now we are observing that lab activity 3. Next we are observing the lab activity 4. Here we taking a tray, water, take a metal tray and fill it with water, place on table near the wall, opposite to the sunlight or source of light. In this way also we will be do this experiment in our house. A plastic tray, water, or a bowl. In this way, opposite light falls on that mirror and disperse into 7 colors, and it will be falls on the screen or white wall. We will be observe that 7 colors. These 7 colors due to the phenomena of dispersion of light. If you add that 7 colors, it will be gives that whitish color. This is explained by the Newton. 7 white color splitting to 7 colors. This is dispersion of light, and 7 colors when you add, it will be gives that white color. In this way, this activity 3 and activity 4 we can observe that. And also we can slides we can do that another activity, that is activity 5 in our textbook. That in the textbook we can stand before an wall. That wall will be whitish color, and the light we hold a pipe which is flowing the water. If you put a finger on that wall, on that water, it will be splitting like a fountain, and it will be gives the Vibgya light on the wall. This activity we are observing. Just like in our when water is fountaining, we can observe that 7 colors, rainbow colors. So here, why this sunlight, white sunlight, enters into the water drop and gives that 7 colors, that is known as rainbow. Light is an electromagnetic wave. This oscillating electric and magnetic fields propagate in all directions with the speed of light. We are observing that the sun, the angle of deviation is minimum for red. We are observing that 6th question answer is that the angle of deviation is minimum for red, maximum for violet. All light waves are electromagnetic waves. These are having a electro nature and magnetic nature. So that's why electric and magnetic fields propagate in all directions with the speed of light. Each color having different wavelengths and different frequencies. Light ray always chooses the path of least time. Light ray always chooses the path of least time. This is already we learn in 8th class and 9th class the formula of Fermat's principle. So white light is a collection of waves with different wavelengths. Violet is having shortest length, and red is having longest wavelength. Red is having shortest wavelength and red has a longest wavelength. So which color has minimum deviation means red color and having longest length. Red color has longest wavelength and violet color has shortest wavelength and have high refractive index and high deviation. So here we are observing figure 12. Figure 13 in the textbook, figure 12, old textbook. The sunlight is coming from the atmosphere, and when entering through the water drop, it will be splitting to red to violet color. And after reflection, here the reflection point is total internal reflection. Here, when the total internal reflection is occurs, it will be gives violet to red color to our eye. When this is appears, violet color will be appears at any time at anything at any place, but red color is not possible to see. Where the angle of the incident is 40 degrees, then only we can see the red color. So the angle of incidence are different. The angle of incidence and the angle of refractive, when it will be 40 to 42 degrees, then we will be see the red color. The angle of refractive means the angle of refraction is when 40 to 42 degrees we can observe that red color. We can see this red to violet color, the dispersion of light. And next figure 13 and figure 14, the angle between the incoming and outgoing rays can be anything between 0 degree and 42 degree. Bright rainbow, when the angle between incoming and outgoing rays, the maximum angle of 42. At the angle of 40 to 42 degrees, we can observe the brightness rainbow. Now we can see figure 13. Here sunlight is incident and enters into the droplet, water drops. It works like a prism, and this white light ray disperses into 7 colors. The red color having less deviation, and with the total internal reflection, it will be reflected and reach to the eye at the angle of 40 degrees. Whereas if it is in the 42 degrees, the violet color will be also appears. Violet color at any angle we can see, but red color is appears at the refractive angle at the 40 to 42 degrees only. At the maximum 42 degrees, we can see the bright rainbow. Violet at 40 degrees and red at 42 degrees. The rainbow you see is actually a 3-dimensional cone with the tip at eye. All the drops that disperse the light towards you lie in the shape of the cone, a cone of different layers. Here we observe that figure 16, at the angle is 40 degrees, we can observe that violet color, and at the angle of 42 degrees, we can observe that red color. It will be in the cone shape. So 3-dimensional cone shape. The observer will be observe this bright of the rainbow. The drops that disperse red color to our eye are on the outermost layer of the cone. The red color is outermost of the cone. Similarly, the drops that disperse orange color to our eye on the layer of the beneath the red color cone. After red color, orange color will be disperse and reach to our eye beneath the red color. After that, in this way, the cone responsible for yellow color also. Yellow color will be dispersed by the drop, and it is beneath the orange color. after that blue color, after that violet color. In this way, all colors will be coming in this way. It will be the violet color cone becomes the innermost cone. So that's why you can observe that dispersion of light and forms the rainbow in this way. Next, what is a prism? Here, prism means a prism is a transparent medium separated from the surroundings mediums by the at least two plane surfaces which are inclined at a certain angle. Here, the prisms are made up with plastic, glass, or if you fill with water or benzene or other materials also. It is in the shape of triangular shapes or base as a rectangular shape and cone shape also, triangle shape also. So the light ray will be incident on one of the plane surfaces and emergent from the other plane surfaces. So prism. A prism is an optical element. It has polished flat surfaces that refract the light. Why? Because before of the prism, there is a air medium. Prism made up of with totally glass. Then it is having the glass medium, and it will be refract the light and emerging into the air once again. If the prism is filled with that benzene or water, that substance or that medium is also refract to the substance, refract to the light. So prism is an optical element. It has polished flat surfaces that refract the light. The traditional geometric shapes of prism has a triangular base and two rectangular slides. It called triangular prism. A prism can be made from materials like glass, plastic, and fluorite. It can be used to split light into its components. Now consider here a prism where the light ray incidents, that surface area, if you draw, it is gives that triangular shape. The angle between PQ and PR, that is known as angle of prism, capital A, in the above part. And the incident ray falls or incidents on the surface of PQ. This is the first surface, incident surface. So the light ray falls at the point M. If you taken like this, then the incident ray is left side of the prism PQ and incident ray at the point PM. If it is a similar medium, it will be continuous. So here is a different medium, so that's why the light ray will be refractive. So at the point M, we can consider a normal. So here draw a normal. And the angle known as incident angle, that is I1. And it is refractive in the prism, that is indicated with M and N. And emerging outside, there is also change of the medium. So once again, it will be refractive and come outside. That is known as emergent ray. Here, the point is, emergent point is N and draw a normal. Here, the angle is known as emergent angle, that is I2. If there is no any medium, the incident ray will be coming as we can extended with dotted lines. This showing of the dotted line is the emergent line, and before of that is the incident line. The two dotted lines extended, and it will be gives an angle. That angle is small d. That is the deviation of angle dm. So here I1 is incident angle, I2 is emergent angle, and D is deviation. In this way, we can learn about the prism geometrical measurements. Here also another picture is there. For geometrically, I give this picture. Triangular face. So A is the angle of prism. I1 is the incident angle, and here I2 is the emergent angle, and D is the sometimes deviation of angle, minimum deviation of angle is also indicated with capital D or small dm. So deviation of angle showing with that capital D. So for the lab, in the textbook, there is a lab activity. For this lab activity, we are taking some materials. So lab activity aim, first of all, for what, for this aim, finding the refractive index of a given prism. Materials, one prism and 20 centimeters into 20 centimeters of white paper or chart, pencil, pins, scale, protractor, and now to study the, in the aim, there are two main components are there. One is to study the angle of deviation with the angle of incidence, and to find the angle of minimum deviation from ID curve. To find the refractive index of the material of the prism using A and D. Now we observe that this graph also, refractive index of prism. If you taking the values of I and D, we can get this curved graph. For this curved graph, we can draw a parallel line to the x-axis. That means parallel to the angle of incidence. And where the least value we will be observe or consider, at that point we will be draw a parallel line to that y-axis. This is give the minimum deviation of angle dm. For this, we can taking the formula, that is refractive index of given prism n is equal to sine of a plus d by 2 by sine of a by 2. Let us observe that on video how to do this activity. After that, we will be take the values and complete that problem also and find that refractive index value, n value. Now we can observe that video. What are the activities we will be, what are the materials we will be take here? First of all, one prism and another one piece of chart and scale, pencil, and after that protractor. And also for what we do this experiment, what is the aim? Means finding the refractive index of prism. And what is the principle of this refractive index? Means n is equal sine of a plus d by 2 by sine of a by 2. Video, sir.
1 minute.
Let us observe that video. First of all, we're taking an prism.
1 minute.
After
1 minute. One minute, sir.
Okay, sir. పైకి పోతుంది. For this lab activity, we will be take that materials, refraction of light through a prism. This is our lab activity. We will be take that scale, prism, glass prism here, pencil, eraser, pins, and protractor, and 20 into 20 centimeters of white paper or a chart. Now we take a prism on that chart and draw the shape of the triangular base. We put the prism on white chart and draw the outline of the prism, and we will get the outline as a triangular shape. And we will be put two pins at the angle of 30 degrees, measure with that protractor, and that is the incident ray line. With the two green pins, we are observing a line at the degree of 30. We draw a line, that is incident line, and put the prism once again on the outline and observe the image of the pins from this other surface where the line is. We observe that area we see, and put the yellow pins and draw the outline that is known as emerging light. And we will be draw that M and N line, and also extending the incident ray and emergent ray. The two are where meet that angle known as minimum deviation of the incident ray and emergent ray, that is 42 degrees in that lab activity. This is the our lab activity. Sir, can you play once again? Here we once again you observe this: taking scale, prism, protractor, and eraser, pencil, and green color pins and yellow color pins. First we put the prism on the chart and draw outline. It will become as a triangular shape. From this prism, the incident ray consider at the degree of 30 degrees, and put these two green pins, that is the incident ray. And we observe the image of these two pins line or incident ray. We will be put the yellow pins to this outside. Here refraction is occurs, so that's why some bending will become. So for the emerging ray, we will be put two yellow pins and draw the emergent line. We draw the emergent line. After that, we extended the incident ray and emergent ray. We will be get the angle of deviation. This angle of deviation dm, we will be measure with that protractor. We will be get the angle as 42 degrees. The prism angle here, equilateral prism, so that's why the angle of prism we consider as 60 degrees, and deviation 42 degrees. Incident ray is 60 degrees. In this way, we do this experiment for 30 degrees, 40 degrees, 45 degrees, 50 degrees, 55 degrees, and 60 degrees, and fill the table in the textbook given as table 1. So slides. In the textbook, we are observing the table 1. There is an angle of incidence I1, angle of emergency I2, and angle of deviation D. In this way, we fill that table from the angles 40 degrees, 45 degrees, 50 degrees, 55 degrees, and 60 degrees also. This is our table. After that, we do this after that completion of the experiment. We fill the table and take the result as we doing an problem here. Next slide, sir. With this experiment, I get that angles as at 60 degrees, I get that 45 degrees minimum deviation angle. And at 55 degrees, and incident angle at 55 degrees, I get that 44 degrees of deviation. At 50 degrees, I get that 42 degrees of deviation. At 45 degrees incident ray, I get that minimum deviation as 45 degrees. At incidence of 30 degrees, I get that minimum deviation as 56 degrees. For this, I draw a graph where x-axis denotes with the incident angle I, taking as 10, 20, 30, 40, 50, 60. And on that y-axis, I consider that minimum deviation values, that also same units 10, 20, 30, 40, 50, 60. After drawing this graph, how we take that minimum deviation value. There are speculations are there, 45, 44, 42, 45, 46. Which is the minimum value? That is the 42. Where to decrease, and after that increase, that least value will be considered as a minimum deviation of the angle. So that's why that is the 42 degrees. For this minimum point in the graph, we consider parallel line to the x-axis, and also draw a parallel line to that y-axis. So that's why we get that minimum deviation value as 42 degrees. These values we will be put in the value of n is equal sine of a plus dm by 2 by sine of a by 2. We also know that the angle of prism, this is the equilateral angle. So that's why angle A is equal 60 degrees. So sine 60 plus 42 by 2 by sine 60 by 2. So we can get that sine 51 degrees by sine 30 degrees. Sine 51 degrees value we write, and sine 30 degrees value is 0.5 or 1 by 2. After calculation, we will be get that value as 1.5556. So the refractive index of glass prism known as 1.5556. So the phenomena of dispersion of light to consider or to learn, we will be compulsory in learning about the prism and refractive index values. Why? Because in the dispersion of light, there are two phenomena are there. One is refraction of light, and another one is total internal reflection of the light. So the rainbow occurs due to these two phenomena. So the dispersion of light or splitting of the white light into 7 colors will be learned through a prism. The water droplet also working as a prism. So that's why we compulsory learn about that prism. So this lab activity is very, very useful to us. From this lesson, we will be taking that learning outcomes like students understand about the working of a prism, and students will be better able to do this experiment in a real laboratory by understanding the procedure. In this way, we will be learn about the dispersion of light and the prism. Okay, thank you, sir. Gurumut sir, thank you.
Thank you.
Enjoy, sir.
Okay.